All right, so now we have the addition rule. This is day 3, so we're gonna talk about the addition rule for when you have the probability of an event A or an event B, and these are dependent events. So we're gonna talk about what that is and how do we go about doing that. So there is a rule for this. You have a formula sheet, but you can write this rule down, and we're gonna talk about how it works in our situations. So I'm going to show you how to use the addition rule for to find the probability of the dependent events. A dependent event is when um, the event, when the probability of one event depends on the other event. Let me give you this in a simpler way. Just say dependent events mean the events can happen at the same time. And let's just say it that way. The dependent events mean events can happen at the same time. No, let's not go there, because that's going to get into mutual. Dependent events is when the probability of one event doesn't affect the probability of another event. Independent events means the probability. Oh wait, it's not that it doesn't. It does affect the probability of another event. Independent events means the probability of one event affects the probability, and that's probably should be affect, guys. Look over the English, just get the idea of what I'm saying. Probability of one event affects the probability of another event. In other words, let me say it like this. Is it possible I have two events? The sky is blue, the sun is red. Is it possible? Well, let's say this. I have a cat and I have a dog. Well, the probability, is there a chance that I can have a cat and a dog together? So, since the probability of having a cat doesn't affect the probability of having a dog, those would be independent events. That probably wasn't the best example, but I'll show you when I get into some of these problems. So the addition rule is this, and it helps you find the probability when two events are being in union, when you're adding the two or events together. And it tells you to take the probability of A, add it to the probability of B, but subtract it from the probability of A and B. All right, that's how you do that. Some people put and here instead. Okay, let's keep going. So we have this situation, and I'm just going to read this situation, and there's some key things that we need to make sure we remember so we can answer the questions. It says Jada has a way to find a probability of a random outcome being in event A or event B. She says we use the probability of the outcome being in event A and then add the probability of the outcome being in category B. Now, some outcomes have been counted twice, so we have to subtract the probability of the outcome being in both events so that those outcomes are only counted once. And here's that addition rule. That's what we just wrote. And you can put the symbol union here, the intersection there if you want to. It says for each of the probabilities, when find each of the probabilities when a state is chosen at random. I think I'm missing some information though. Yeah, this is backwards. I was supposed to do this one first. So I'll go back to that one. It says Alaska. Wait, we're missing some data altogether. Oh, where did that go? All right, so what we need to know before we can answer any of these questions, and I'm going to start with this one. Before we can answer these, we're going to call, there was a slide and I think I left it off. It says all of the states that have names through A through M is event A, and all of the states that have a population less than 4 million is B. Okay, so this is event A and this is event B. I don't know where that slide went. Sorry, babies. But there's your events. Okay, it says Alaska is one of the 11 states in the top left corner of the top left cell of the table. So Alaska fits through here because it has a name that begins A through M. California is one of the 15 states in the top right. Nebraska is one of the 13 states in the bottom left. And New York is one of the 11 states in the bottom right cell of the table. For each event, write which of the four states listed here is an outcome of that event. Okay, so what's the event A or event B? So which state would fall between A and M and have less than a million people? All right, so California falls right here, so that's not it. Nebraska falls under 13, but that's the wrong letter. It looks like the only one that falls between A or B. Well, hold on. All states that falls through A through M, that would be California. So let's do that first. All states that fall through A through M would be California is one of them, and where's the 11 at? And New York. So we get New York and California, so that's two. And then we have to go do event B, less than a million, less than 4 million. So that means 13 falls under Nebraska, so that's three. And that's the only one. Nebraska, and we already counted the 11 of Alaska. So we have one, two, three. So we have three of these that falls in event A or B out of those four. Okay, event A, we have just one event. No, not one. We have two that falls between event A, which is states that are in between A and M. That would be California and Alaska. And then it says how many would fall in event B. That would also be two. So we have Nebraska falls here for less than a million, and then New York, or no, Nebraska and Alaska. So this would be two. And then we say A and B, where they intersect, that would just be one. And I think that is Alaska. Okay, so you just have to read and match up the events. I'm going to go to the other one. It says, find each of the probabilities when a state is chosen at random. So now we're going to do probabilities. All right, so remember when I told you this was event A, this is event B, and then remember in the last one I told you guys if they don't put the total, you have to be the one to put the total row and column in here. So we have that situation going on. So I am going to put this in here, and I'm going to call this total. and this is 24, and this is 26, and over here I'm going to call this my total also, and this is a two-way frequency table here. Here I'm going to have what, 24, and here I have 26, and if I add this together I get 50, and if I add this together I get 50. So I have my total. Now I can start answering these questions. It says the probability of A or B. Alright, so I'm going to go do what's the probability of event A. So the probability of, because that's a formula here and it tells me to do the probability of A. So part A tells me to do the probability of A plus the probability of B minus the probability of A and B. Alright, so the probability of A, getting event A in this situation, is 26 out of 50, plus the probability of getting event B is going to be 24 out of 50. Now minus, we know that these are dependent event because event A and B can happen at the same time. That's that joint frequency right here. So we have 11 states that go between A through M, but they also have less than 4 million. So I need to subtract out the 11 over 50 because of these 26, 11 of them is already being counted for A through M, and of this 24, 11 of them is already being counted for less than a million. So I got to take that out so I can get the probability. Now you can do mental math or you can use your calculator. I'm going to say 50 minus 11 is 39. And I get 39 out of 50, and that's in its simplest form. So I'm done with that one. The next question, which is part B, it says, what's the probability of getting just A? The probability of getting A is 24 out of 50, and that can be reduced. Let's say the biggest number there, I think, is 2, so we get 12 out of 25. So that's the answer for probability of event A. Oh, right, I'm wrong. Probability of event A is 26 out of 50. Sorry, read that wrong. This is event A right here. So 26 out of 50, that needs to be reduced. If I go to there again, it would be 13 out of 25. Okay, C would be probability of B, event B. So here's event B right here, which is less than a million. So that's 24 out of 50, which is 12 out of 25. And this is already reduced, so we good. And then part D would be the probability of A and B. So the probability of your letter, your name of your state begins with A through M, and you have less than a million, so that would be 11 out of the 50. Probability of A and B will equal 11 out of the 50. And we're finished. All right, let's go to the next question. Oh, okay, we're done with that. So go ahead and go to Canvas and knock out your practice questions, and I'll see you guys later. Well, see you at 12.